Article 800.100 of the National Electrical Code addresses equipment grounding for telecommunications systems. Specifically, it deals with situations where the electric service ground isn't bonded to the grounding electrode system and an equipotential plane isn't established. In such cases, the grounding electrode conductor must be connected to each service enclosure and all grounding electrode conductors that are connected to the grounding electrode system. The exception to 800.100 covers scenarios where there's no equipment grounding conductor from the electrical service connected to the service entrance enclosure. This could happen when the electrical service is supplied from an overhead line and a neutral is used as the equipment grounding conductor, according to section 250.32. B2. When this occurs, the grounding electrode conductor is connected to the service enclosure and any other grounding electrode conductor connected to the grounding electrode system. Let's discuss using the service neutral as the equipment grounding conductor. Section 250.32. B2 of the National Electrical Code allows the service neutral to be used as the equipment grounding conductor under specific conditions. Firstly, the system can be a corner-grounded delta system. Secondly, the service entrance conductors should not be smaller than 1/0 American wire gauge copper or 2/0 American wire gauge aluminum. Thirdly, the service entrance neutral shouldn't be smaller than the service entrance phase conductors. Fourthly, the service entrance neutral needs to run with the service entrance phase conductors. And fifthly, the service entrance neutral must be connected to the grounding electrode system at the service entrance. Now let's consider grounding at the utility pole. The electric utility might have a grounding electrode system at the utility pole that feeds the premise. If this is the case, the grounding electrode conductor from the premise can be connected to the grounding electrode system at the utility pole. This fulfills the requirement of 800.100 to bond the grounding electrode conductor to the grounding electrode system. In conclusion, if the electric utility doesn't have a ground rod at the premise but maintains a grounding electrode system at the utility pole feeding the premise, it's acceptable to connect the grounding electrode conductor from the premise to the grounding electrode system at the utility pole. This provides a safe and code-compliant grounding solution for telecommunications equipment. It is important to remember that the specific requirements of the National Electrical Code should always be consulted and followed, and local codes might have additional requirements. Always consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and regulations. Grounding is a critical aspect of electrical safety, and proper grounding practices can help prevent electrical shock, fire hazards, and equipment damage. Understanding the requirements of Article 800.100 and other relevant sections of the NEC is essential for anyone involved in the installation or maintenance of telecommunication systems. The information provided is for general guidance only and shouldn't be considered a substitute for professional advice. Always seek the advice of a qualified professional for any specific electrical needs or concerns. When dealing with electrical systems, safety should always be the top priority. Take the necessary precautions to protect yourself and others from electrical hazards. This includes wearing appropriate personal protective equipment such as gloves and eye protection and working with energized circuits whenever possible. If you are not comfortable working with electrical systems, it is best to leave the work to a qualified professional. Remember that electricity can be dangerous, and improper handling can lead to serious injury or death. By following safe work practices and adhering to the requirements of the National Electrical Code, you can help ensure a safe and reliable electrical system for everyone. Proper grounding is also essential for protecting electronic equipment from damage due to voltage surges and other electrical disturbances. A well-designed grounding system can help to dissipate these surges and prevent them from reaching sensitive electronic components. This is particularly important for telecommunications equipment, which is often very sensitive to electrical noise and interference. A properly grounded telecommunications system can provide a clean and reliable signal, which is essential for optimal performance. In addition to the requirements of the National Electrical Code, there may be other applicable standards and regulations that must be followed when grounding telecommunications equipment. These standards may vary depending on the specific application and location. It is important to be aware of all applicable requirements and to ensure that the grounding system is designed and installed in accordance with these requirements. Grounding systems should also be regularly inspected and maintained to ensure that they are functioning properly. This includes checking the connections to ensure that they are tight and free from corrosion, and testing the grounding resistance to ensure that it is within acceptable limits. Any problems that are identified during these inspections should be corrected promptly to prevent potential safety hazards. Grounding is a complex topic, and there is a lot of information to learn. However, by understanding the basics of grounding and following the requirements of the National Electrical Code and other applicable standards, you can help ensure a safe and reliable electrical system for everyone. Remember, safety should always be the top priority when working with electrical systems. Take the necessary precautions to protect yourself and others from electrical hazards. And if you are not comfortable working with electrical systems, it is best to leave the work to a qualified professional. Now let's delve a bit deeper into the specific requirements of Section 250.32 (b)(2), which allows the service neutral to be used as the equipment grounding conductor under certain conditions. This exception is primarily intended for situations where a separate equipment grounding conductor is not readily available, such as in some older electrical systems or in certain types of temporary installations. However, it is important to understand that this exception is subject to strict limitations and should only be used when all of the specified conditions are met. Firstly, as mentioned earlier, the system must be a corner-grounded delta system. This type of system is relatively uncommon in modern electrical installations, but it is still found in some older systems. In a corner-grounded delta system, one of the phase conductors is intentionally grounded, which creates a reference point for the voltage in the system. Secondly, the service entrance conductors must not be smaller than 1/0 American wire gauge copper or 2/0 American wire gauge aluminum. This requirement is intended to ensure that the service entrance conductors are large enough to safely carry the fault current in the event of a ground fault. The larger the conductors, the lower the impedance, and the more effectively they can carry the fault current back to the source. Thirdly, the service entrance neutral must not be smaller than the service entrance phase conductors. This requirement is similar to the previous one, and it is intended to ensure that the service entrance neutral is large enough to safely carry the fault current. In addition, it helps to ensure that the neutral conductor has sufficient capacity to carry the unbalanced load in the system. Fourthly, the service entrance neutral must be run with the service entrance phase conductors. This requirement is intended to ensure that the neutral conductor is located close to the phase conductors, which helps to reduce the impedance of the grounding path. When the neutral conductor is run separately from the phase conductors, the impedance of the grounding path can be significantly higher, which can reduce the effectiveness of the grounding system. Fifthly, the service entrance neutral must be connected to the grounding electrode system at the service entrance. This requirement is essential for ensuring that the grounding system is properly connected to the earth. The grounding electrode system provides a low impedance path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and clear the fault. It is important to note that even when all of these conditions are met, it is still generally preferable to install a separate equipment grounding conductor whenever possible. A separate equipment grounding conductor provides a more reliable and effective grounding path, and it can help to reduce the risk of electrical shock and equipment damage. In addition to the requirements of Section 250.32 (b)(2), there are other important considerations to keep in mind when grounding telecommunications equipment. One important consideration is the type of grounding electrode system that is used. The grounding electrode system should be designed and installed in accordance with the requirements of the National Electrical Code, and it should be appropriate for the specific application and location. Common types of grounding electrodes include ground rods, ground plates, and metal water pipes. Another important consideration is the bonding of all metal enclosures and equipment. All metal enclosures and equipment should be bonded together to create a continuous grounding path. This helps to ensure that any fault current will flow back to the source without creating a voltage potential between different pieces of equipment. Bonding can be accomplished by using bonding jumpers, which are short lengths of wire that are used to connect different pieces of equipment together. Finally, it is important to regularly inspect and test the grounding system to ensure that it is functioning properly. This includes checking the connections to ensure that they are tight and free from corrosion, and testing the grounding resistance to ensure that it is within acceptable limits. Any problems that are identified during these inspections should be corrected promptly to prevent potential safety hazards. Now let's talk about surge protection. Surge protection is essential for telecommunications systems. Electrical surges can cause significant damage to sensitive electronic equipment. Proper grounding plays a vital role in the effectiveness of surge protection devices. A low-impedance ground path helps to divert surge currents away from the equipment and safely dissipate them into the earth. Surge protection devices, also known as surge suppressors, are designed to protect electronic equipment from voltage spikes. These devices typically contain metal oxide varistors, or MOVs, which are designed to clamp the voltage at a certain level. When a voltage spike occurs, the MOV will conduct the excess current to ground, protecting the equipment from damage. However, surge protection devices are only effective if they are properly grounded. A poor ground connection can actually make the surge protection device less effective, and it can even cause the device to fail. Therefore, it is essential to ensure that the surge protection devices are connected to a low-impedance ground path. In addition to surge protection devices, other measures can be taken to protect telecommunications equipment from electrical surges. One common measure is to install a lightning rod system. Lightning rods are designed to attract lightning strikes and safely divert the current to ground. Lightning rod systems can be very effective at protecting buildings and equipment from lightning damage, but they must be properly designed and installed to be effective. Another measure that can be taken is to install transient voltage surge suppressors, or TVSSs, at the service entrance. TVSSs are designed to protect the entire electrical system from voltage spikes. They are typically installed at the service entrance, where they can intercept voltage spikes before they reach the equipment. TVSSs can be very effective at protecting our electrical systems from voltage surges, but they must be properly sized and installed to be effective. In addition to these measures, it is also important to follow good grounding practices throughout the electrical system. This includes ensuring that all metal enclosures and equipment are properly bonded together and that all grounding connections are tight and free from corrosion. By following these good grounding practices, you can help to protect your telecommunications equipment from electrical surges and other electrical disturbances.